Next, we're going to take a look at writing the inverse equation for a function. So I have the steps listed off to the side for you because it can be kind of complicated to keep track of, and as another reminder of what you should be doing with this right-hand column. As I talk through the process, when I explain the steps, you should be writing those steps in the right-hand column. So the first thing we need to do, step 1, replace f of x with y. So we're going to call it y equals 4x minus 5. And again, remember with the function machine symbol, the x and f of x switched places. When we wrote the inverse for the set of ordered pairs, we switched the x and the y. When we write the inverse, step 2, switch x and y. And then we're going to solve for y, so I'm going to add 5 to both sides and divide both sides by 4. And the last step is replace y with the f inverse of x notation if it's a function. Remember, all functions have an inverse, but not all of them are functions. So we can't use the f inverse or the function notation if its inverse isn't a function. So let me give you a little hint. If you have to take the square root as you're solving for y, or if y ends up in an absolute value, then the inverse will not be a function and you'll just leave it as y equals. Other than that, you can use that function notation. And if you take a look at this, it's just a line. We can even split it up as to 1/4 x plus 5/4 into the slope-intercept form of a line, so it's a little bit more recognizable, and of course a line is a function. Next, we're going to take a look at one that's quite a bit more complicated, so make sure that you are taking notes on the steps and writing down questions as they come up so you can let me know if there's anything that I need to clarify when you get to class. First thing I want you to notice is we have an x in the denominator. So this is a hyperbola function. Remember the parent function, 1/x. Sketch that for you real quickly. So this is a function. We have a little bit of an issue with those asymptotes, but we can, and it passes the horizontal line test. So its inverse will also be a function. Step 1, switch the x and the y. Sorry, replace f of x with y before we can switch the x and the y. Now, when we switch x and y, both of those x's need to become a y, and the y becomes an x. Now we need to solve for y. The problem is we have 2 y's. So what we need to do, and write this down, if you end up with 2 y's, you need to get your y terms on one side, and then you're going to factor out y. Well, first, before that, I need to get y out of the denominator. So I'm going to multiply both sides by y. And I'm going to follow this note, get y terms on one side. Get all of the terms that have a y in them on one side of the equation. So I'm going to add 3y to both sides. And the next is to factor out the y. Once I factor out the y, I will only have one y, and I can finish solving for it. So this becomes y times x plus 3. And in order to finish solving for y, I'm going to divide both sides by x plus 3. And then my last step was to replace that y with the function notation, if it's a function. But we talked about that our original equation does pass the horizontal line test. So this is a function. It's another hyperbola function with a vertical stretch by 5, shifted left 3 if you recognize the transformation. Last piece is proving whether or not 2 functions are inverses. So in order to do that, I've got the steps off to the side again, composing f of g of x. If you get just x, remember when we dropped x into the function machine and then we dropped f of x into its inverse, we get x back. So when you compose the functions, if you get x back, then you can go on to step 2, which is composing them in the other way. So we're going to start with our f of g of x composition. So I'm going to take the whole g function, put it into my f function for x. So it'll become 7 times the quantity 1/7 x plus 2/7, distributing, sorry, and the minus 2, I almost lost the minus 2. Make sure you finish the function. That's a common mistake. Make sure you finish that function once you substitute. Distributing by 7, I get x plus 2 minus 2, which equals x. So what happens when you compose inverse functions is everything cancels. Everything should start to cancel, and it should be relatively easy algebra. If it's complicated algebra, they're probably not functions. Or they're the hyperbola functions. Those have some complicated algebra even when they are inverses. All right, so we got x back, so I'm going to move on to step 2, which is composing them the other way. Putting the f function into the g function for x. So I'm going to start by just writing that f of x function down in my composition notation, replacing x with 7x minus 2, and finishing my g function with that plus 2/7. When I distribute the 1/7, it cancels with the 7x, so I get x minus 2/7 plus 2/7, which cancel, leaving me with x. So yes, these two functions are inverses. And if you graph and they're reflected across y equals x, then they're also inverses. I'm actually not going to graph these. One reason is because that second graph has a y-intercept of 2/7, and because on the first example, I graphed those and showed you the reflection across the y equals x already. So here are your couple of U-try questions.